but we have a giant custom designed tower with massive mechanical arms that will literally try to catch the booster and catch the ship. Which it sounds insane. I mean, I haven't even seen a sci-fi movie that does this, you know. But in theory, it should work. Let's just say success is in a set of possible outcomes. I'm not sure what the probability is, but success is somewhere in that. Is success possible? Yes, I think it's possible. In terms of catching it, I think. For the ship side, we obviously want to make sure that it actually comes in fully intact and lands at a precise location in the Pacific before we try to catch it at the launch site, because we're taking every precaution we can so that we do not risk any human lives or destruction of property. So it'll be a few flights. So for the ship, it'll be when we see the ship landing at a precise position in the water. That's when we will try to catch the ship with our Mechazilla on the tower. The booster, obviously, booster flights we've done many times on Falcon 9, so we're much more familiar and have a much higher confidence with booster recovery. We've actually had the booster boost back to land and land at Cape Canaveral Air Force Base many times, albeit with landing legs, not with the Mechazilla arms. So booster, I think there's a decent chance, depending on when our licenses are granted, that we would catch the booster within the next year, or maybe less than a year, and then hopefully, if we get lucky, we might catch the ship towards the end of next year.
And where does the catch take place? Is it Willie Mays in the middle of the outfield over his shoulder, or is it Florida somewhere?
No, so both the booster and the ship come back to the launch site.
Okay, fantastic.
Yeah, that's what I mean by this. In fact, I mean the thing that since we need a giant tower with customized arms to lift the booster and the ship onto the launch pad, we don't absolutely need it. We can technically do it with humongous cranes on a low wind day. But that's quite unwieldy. The tower with the arms is capable of lifting the booster and the ship even on a very windy day, or moderately windy day. So then it just seems to me that, well, if we can lift the ship and the booster, the ship onto the launch stand, or the booster onto the launch stand and the ship onto the booster with those same arms, we should be able to catch the booster and the ship with those same arms. You know, we've gotten pretty good with the thruster-based landing, and in fact, we can make the rocket hover in midair. In fact, we were able to do that many years ago. If you look at the old Falcon 9 test videos, which we called Grasshopper, where we'd actually take the Falcon 9 booster and we'd have it just go up and hover at 100 meters and then translate over another 100 meters, then translate back and then come back and land. So we were able to do that really over a decade ago. It's not obviously very efficient with propellant to have a rocket hover, but it can be done. So I was like, okay, well, let's just have the rocket come back and, you know, hover briefly, and have then the arms come together and catch it. So that's the general idea. Is going back to what I was saying, it's not just reusability, it's rapid reusability, and it doesn't get more rapid than bringing it back to the launch site. And so in principle, the booster comes back very fast. By the way, one way or another, that booster is coming back to land, or it's going to land fast, because with the high thrust to weight that we're aiming for, which is sort of on the order of 1.3 to 1.4. And a staging ratio which is currently about 3 to 1 in favor of the booster. So propellant the propellant on booster to propellant on ship is about 3 to 1 on the current version, but it's trending closer to 2 to 1 on with future versions. That means that we're shifting more and more of the delta V burden to the ship side. That means the the booster actually uses up its propellant quite quickly, and will trend towards only about 100 seconds or so of booster flight, and the booster will immediately flip around, boost back to the launch site, and land. And so it really, we're talking about the booster being back at the launch site in about 4 or 5 minutes, which is pretty wild to think. It's like a 5-minute booster basically. It's landed somehow, whether it's either crashed or it's landed it's been caught by the arms, one of the two, and within 5 minutes. And so then it lands back on the launch stand, and you can then refill propellant. The booster, the ship side obviously is going to take a minimum of an hour and a half to get around the planet. Still going pretty fast, but you got to circle the globe. And obviously that depends on what inclination, and so what's your launch azimuth, what's your inclination of the booster as to whether it has a flight coming back over the launch site or not. If it's technically possible to do it in a single orbit, depending upon your launch inclination.
Very good.
So booster could come back in an hour and a half. The ship could come back in about an hour and a half.
Any prediction on when you're going to start deploying satellites with Starship?
Yeah, I think we will start deploying. I think there's a good chance we start deploying Starlink V3 satellites next year, in roughly a year from now. Because before we are confident that the ship, like I said, the hardest part about this, or the part that will take the longest, is solving for safe ship reentry and landing. But before we solve that, we can launch the satellites, because in any case with Falcon 9, the upper stage is expendable. So it's actually fine to start launching satellites even before we solve for ship reusability. That is the hardest part of the equation. So with Falcon 9, we've gotten pretty far with reusability. The booster, it's now highly unusual for the booster to not come back and land. It's gotten quite normal for the booster to come back and land. We now have a couple of boosters that have done 17, I think 18 flights at this point. And the fairing is also recovered, so the fairing reusability is also solid. But the Falcon 9 design does not allow for reusability of the upper stage. And the Falcon 9 while reasonably rapid, especially if you've got a return to launch site landing, still takes at least a few days to refurbish before you can fly it again. And so with Starship, actually more profound than the size is the fact that it is designed to be fully and rapidly reusable. The reason for the absurd size is that we're trying to build something that is capable of creating a permanent base on the moon and a city on Mars. That's why it is so large. Otherwise, we could make it much smaller.
Any predictions on when Starship might land on Mars without crew, maybe a crewed flight? Any prediction there?
Well, I think 3 or 4 years.
4 years. That would
be
All
something like.
right.
I have to check with the Earth Mars. Earth and Mars. Have orbital synchronization about every 26 months. So you can't just fly to Mars when it's on the other side of the sun from Earth. That's unwieldy. So roughly every 26 months, the orbits are in the right relative position, and then you have the Mars transport window. So I think but I think it's sort of feasible within the next 4 years to do an uncrewed test landing there. Yeah.